Hello everyone, I'm Kristen Nagy, and today I'm going to be talking about the micro hydroelectric project that I completed. This presentation is my ET240 Capstone Project. Alright, so here's a little bit about the client that we were given. We were told that he owns 8 acres of land in Watauga County, North Carolina. He has a stream on the edge of his land. He is interested in reducing his electric bill expenses, which is obviously where we come in, because hydroelectric projects are a good way to reduce electric bill expenses. His current average daily electric usage is 34.8 kilowatts per hour, and his load factor is only 36.73%, which means his efficiency can be improved. If he can find a way to get his load factor up to a higher percentage, he will be able to decrease his costs, which is what he's looking for by contacting us. Alright, so next we're going to talk about the resource availability. There are 6 things you need to consider when you're seeing if a site has the resources available that you need. One would be the availability of water. You would consider the flow, which is the volumetric measure of how much moving water is available. Obviously, the more flow there is in a stream, the more flow there is for you to use. This is the reason this is the case is because when you want to use the minimum amount of flow as possible because of environmental concerns. So if you have more flow available, it will be okay to use a larger amount of flow. Alright, the second thing you need to consider when looking at resource availability is water storage. And this just means is it a logical place for a dam to be placed and the water to be moved to a site. So in this case, the stream is at the top of a hill and his house is at the bottom, so it is logical. The third thing you should consider is waterhead, and this is the vertical distance from the source of the water to the turbine. The larger the head, the more electricity can be generated, because the larger the drop, the more time the water is moving, so there's more electricity is generated. And fourth thing you want to consider is the accessibility of the site. We determined that the site is accessible. We will be able to transport materials there, and it will be easy to do maintenance and things like that. Alright, the fifth thing you should consider when looking at the resource availability is the distance from the load center. So we were told that the stream is approximately 200 feet from the client's house, which is a pretty short distance. This is good because when the longer the distance that the water is transmitted, the more loss we have and it costs more. Sixth thing you want to consider is the type of land, and this is just the topography and the terrain. Right, so this is the site assessment. We calculated that the minimum hourly median flow is 238 gallons per minute. We were given this chart in the upper right corner, and it showed the cubic feet per second in flow, but I converted them and found the median. I also found the maximum hourly median flow, which was 3,591 gallons per minute. The hydraulic head was calculated to be 65 feet, which is a pretty good distance, and it has a pretty level and slow decline. So when deciding what the design flow will be, you want to make sure to never be anywhere near half the maximum flow. And since there's such a large range here, it would probably be better to stay near the minimum flow. So I went ahead and did 150 gallons per minute, and this is about a little bit more than half the minimum hourly flow. Alright, so let's talk about the technology that would be used for this project. The first thing that we want to consider is the penstock pipe diameter. I chose to use a 4-inch pipe. So this is the chart you look at. So we would go to the design flow that we're using, which would be 150 gallons per minute. And you go over to the feet loss. So let's look at the 4-inch diameter pipe, how much loss there would be. And this is per 100 feet of pipe, which we know that we're going to be using 200 feet of pipe. So it's going to be 2 segments. So whatever feet loss we have, we need to make sure to multiply by 2. So if we're using a 4-inch pipe, there's going to be about 1.2 feet of loss. So this means that there would be 2.4 feet of total head loss would be caused by pipe friction using a 4-inch pipe. And we can use this to calculate that there would be 59 feet of dynamic net head. Alright, next we are going to talk about the nozzles we can use. I decided to use one 5/16 of an inch nozzle, 2 1/2-inch nozzles, and one 5/8 inch nozzle. The way you figure this out is you go to this chart, and we talked about earlier that the dynamic net head was about 60. So we would use this row right here highlighted in yellow, and I just started choosing, and I found a combination that came to about 150 gallons per minute. So I added up 14.8, 59.4, and 2 times 38. And that came out to be 150.2 gallons per minute. So that's how I know that I can use one 5/16 inch nozzle, 2 1/2-inch nozzles, and one 5/8 inch nozzle to come out to my desired flow. Alright, when trying to decide the penstock pipe material, I decided to do the HDPE, which is the high density polyethylene pipe. This is because there is 65 feet of head, which will cause pressure to build up. Also, the HDPE pipe does not have to be buried, which will make maintenance easier and more affordable. Also, since our client is in North Carolina, there are freezing temperatures occasionally, so HDPE pipe can handle freezing temperatures and PVC pipe cannot. Right, and lastly, the turbine type. I chose the turbo turbine because I have some larger nozzles that I chose, and turbo turbines can take up to a 1-inch nozzle. The turbo turbine does require a little more maintenance than the Harris Hydro turbine, but that's the one I had to choose because of the nozzles I chose. Alright, the economic and fiscal considerations. One way that you could save some money is switch from the HDPE penstock material to PVC. This will save more money initially, but you will have more money going out for maintenance. Another option is use smaller nozzles so you can use a Harris Hydro turbine because those are cheaper. There are 2 tax incentives I found for the Watauga County area. One was the financing program for renewable energy and energy efficiency. This is a loan program for renewable energy projects. The next one is NC Green Power Production Incentive, and this is a tax incentive if you are using renewable energy. Alright, and some policy considerations. The Rivers and Harbors Act of 1899 made it illegal to dam navigable streams without a license, so this means we will need to get a license, which we will go through the FERC, the Federal Energy Regulatory Commission. Another policy that I found, this is just a few of the many, the 1992 UN Framework Convention on Climate. This is to stabilize greenhouse gases, so we'll need to be careful about the chemicals and gases that we emit. Alright, thank you. Let me know if you have any questions.